When you do mathematics, you're working with mathematical structures. What exactly is a structure? Normally, a structure consists of a set, say S, and a number of operations that you can perform on elements of S to give you another element that may or may not be in the set. So let's take a look at an example to make this more concrete. So for this example, we're going to let S be the set of all even integers. The even integers are the integers that are divisible by 2. For example, you can have -4, -2, 0, 2, and so on. And we're going to have 3 operations, 2 of which are as follows. The usual addition and the usual multiplication, which we'll represent by a dot. So we are allowed to add and multiply any 2 numbers from the set S. These 2 operations are binary operations because they apply to 2 elements. But there's nothing stopping me from defining a 3rd operation. Let me call it D this time. What it does is, it takes an element from S and returns twice the element. So I can write D of S is 2 times S for all S that is an element of my set S. Now, this operation is not a binary operation because it only applies to a single element, and we call this a unary operation. So in this example, the structure actually has 3 operations operating on the set of all even integers. Now notice that we cannot get elements outside of the set S by performing any of these operations, because if you take any 2 elements from S, when you add them, you also get an even integer. And if you multiply any 2 elements from S, you'll end up with an even integer as well. And obviously, if you double an element, you get an even integer. However, things fall apart when we change this even to an odd. So now let S be the set of all odd integers. So my set will look something like this. If we add any 2 odd numbers, say 1 and 3, we get an even number, which is not in the set. As a result, we say that the odd integers are not closed under addition. But the set of even integers is closed under addition. Now, the odd integers are also not closed under this operation D. But they are closed under multiplication, because if you take any 2 odd numbers, when you multiply them, you also get an odd number. So given this, we can ask the following question. What is the smallest set of numbers containing all the odd integers that is closed under all 3 operations? Clearly, we need to include all the even integers, because whenever you multiply an odd number by 2, you get an even number. But then, once we have included all the even integers, we end up with a set of all the integers. And from this, one can easily say that the set of integers is closed under all 3 operations. And in this case, we say that the set of all integers is the closure of the odd integers under these 3 operations. So this example illustrates a couple of notions. The first is the notion of closedness, and the second is closure. The notion of closure is very important in mathematics. For instance, it is needed for rigorous treatment of numbers. Before we end, let's look at another example of a structure, N-tuples of integers under addition. Well, I put addition in quotes because it is not the usual addition. I actually have to define addition on these things called N-tuples. So first of all, what is an N-tuple of integer? For simplicity, we'll just look at 2 tuples, or tuples, or ordered pairs. Generalizing the ideas to arbitrary n is not hard. So what I say is a 2 tuple. Well, each 2 tuple of integers is expressed as opening bracket x comma y close bracket, where x and y are integers. Sometimes you might see these things written as a column in square bracket. But for the purpose of this video, we'll stick with this notation. So every element looks like this. And addition of these 2 tuples is defined as follows. So given 2 tuples, given by x, y and u, v. X, y plus u, v is defined as the following. You take the two tuple consisting of the integers x plus u and y plus v. It's not hard to see that the set of two tuples of integers is closed under addition as defined here, because whenever you add two tuples of integers, you end up with a two tuple of integers as well. Now, why are we interested in two tuples or n-tuples? Well, there is a geometric interpretation of these things. For example, for the case of two tuples, you can draw them on a plane. And let's consider two tuples. The first is going to be minus 1, minus 1. And the second one is going to be 1, 2. So when you add these two tuples together, using the addition as defined, what you end up with is 0, 1. Now, 0, 1 is right here. There's actually a geometric way of getting this answer. And what you do is, you put arrows pointing to these two tuples from the origin. And then what you do is, you place the tail of one of these arrows to the head of the other arrow. So I can take the green arrow and move it on top of the red arrow. And as you see, if I start from the origin and move along these arrows, I end up at the sum of the two tuples. So this point is 0, 1. Now, if I move this green arrow back and do this with the red arrow instead, I should get back the same thing. So let's see. So let me move this. In a future video, we'll say that this kind of addition is called vector addition when it is defined on vector spaces. And that's a topic that is discussed under linear algebra.